Okay, I'm going to briefly talk about what's the difference between moments and centers of mass. Because they're both double integrals, but they mean different things in a physical context. Actually, there's a nice way to remember this. Moments, they sound weird. Right? They sound weird. Center of mass, it's a concept we all have known since childhood, and we try to balance on one foot. I've never heard of a moment outside of a mathematics class. So, moments sound weird, so they will have the wrong dimensions. Okay, so the center of mass, it will always have dimensions of meters, just length, for example. The dimensions. Okay, so as long as you can keep these two things straight, you won't have any confusion, and like on an exam you won't give a moment when you actually want a center of mass. You'll be tempted because these are easier, but you won't want to do it because it will have the wrong dimensions. So the dimensions of moments, which are x time, for example, the moment in x times your mass density times dA, it'll have dimensions of meters times mass divided by area times area. So really it'll be meters times kilograms. So that's not a center of mass. In contrast, the center of mass, and then we'll just look at the x-coordinate. That'll be exactly this the moment. It'll be x times mass density. And then you need to divide it by the same thing, but without the x. And this is the total mass. So the total mass is actually in kilograms. So what you get, the dimensions are meters times kilogram, that's the moment. Then you get kilogram, that's the mass. So you end up getting meters. That's exactly the dimensions that you want for a center of mass. So that's why I said center of mass is harder, because you need the extra integral. In order to get that total mass. But it'll be the correct dimensions. And from what I've seen, it's the only one used in applications. Because who wants to work with a kilogram times meter, right? Okay, thanks for watching.